In this video, we will look at two transformation effects of our parametric equations. First, translation, and second, scaling. So what is translation? It is basically shifting our curve along the x direction or along the y direction. So if we have a parametric curve defined by this set of equation over here, then if I add a constant k to the equation of x, it will shift my curve k units along the x direction. Or if I add a constant k to the equation of y, it will shift my curve k units along the y direction. For example, we have this set of parametric equation, and this is actually a circle of radius r and center at the origin. If we add a constant x0 to the equation of x, given by this equation, and another constant y0 to the equation of y, given by this equation, we are actually translating the original curve x0 units along the x direction and y0 units along the y direction. Let us first see why this expression will give us a circle of this radius and this origin. Let's rearrange the equation. We have x is equals to r cosine t. This implies that cosine t is equals to x over r. We have y is equals to r sine t, which implies that sine t is equals to y over r. If we do this operation, you would see that we get cosine square t plus sine square t to be equals to x over r square plus y over r square. Cosine square t plus sine square t is actually equals to 1. On the right hand side, we'll have x squared over r squared plus y squared over r squared. Therefore, rearranging this expression gives us x squared plus y squared to be equals to r squared. In general, this is the equation of a circle where a and b represents the x coordinate and y coordinate respectively of the center of the circle. R will represent the radius of a circle. Therefore, comparing these two sets of equations, we can tell that a is equals to 0 and b is equals to 0, which implies that the center of this circle is at 0, 0, or the origin, with a radius of r. Now let's go back to the example. Let's take a look at the example where r is equals to 1. So when r is equals to 1, we have this set of equation, x is equals to cosine t and y is equals to sine t. We know that this is actually a circle of radius 1 centered at the origin. So we will expect to see a circle as shown. Now, if we let x0 to be equals to 1 and y0 to be equals to minus 2, for example, our parametric equation becomes x is equals to 1 plus cosine t, y is equals to minus 2 plus sine t. Then we will expect to shift this original circle 1 unit to the right along the x direction and 2 units downwards along the y direction as shown. Let's take a look at what is scaling. It is actually stretching or compressing our curve in the x direction or in the y direction. For example, if I have a parametric curve C defined by this set of parametric equations, then if I multiply x by a constant k, it will either stretch or compress my curve along the x direction. If I multiply a constant k to my equation of y, it will actually stretch my curve or compress my curve in the y direction. Note that when k is greater than 1, it will stretch our curve, and when k is between 0 and 1, it will compress our curve. If k is smaller than 0, then it will stretch or compress our curve in the opposite direction. Let's look at this example. We have a set of parametric equation, and we know that this is a circle of radius 1 unit centered at the origin. If we multiply x by 3 and we multiply y by 2, it is going to scale our curve by a factor of 3 in the x direction and a factor of 2 in the y direction. This will be our new set of parametric equation. So let's take a look. This is our original equation. X is equals to cosine t and y is equals to sine t. This is a unit circle with radius 1 centered at the origin. So when I multiply 3 to x and multiply 2 to y, we will get this set of parametric equation. This circle will be stretched 3 times along the x direction, and it will be stretched 2 times along the y direction, giving us an ellipse of this shape. Let's go one step further. This is our equation of our ellipse. If we rearrange this to get cosine t to be equals to x over 3, and rearrange this to give us sine t is equals to y over 2, recall that our trigo identity, cosine square t plus sine square t to be equals to 1. Let's substitute cosine t and sine t into our equation. So we will get this expression over here. Simplifying this gives us an equation of this form. Therefore, this is an equation of the ellipse shown by this graph over here.